This is a picture of somebody doing some dissolved oxygen, and that's Eric helping me out marking your cables. My name is Tamara Lipsey. I'm an aquatic biologist with the Michigan Department of Environment, Great Lakes and Energy, and I am part of the MiCorps team. I have done dissolved oxygen monitoring myself, along with other lake monitoring and stream monitoring as well. And I am the one who gets all of the dissolved oxygen meters ready for everybody and are your first point of contact for dissolved oxygen temperature meter questions, but anybody on our team can help you out. So I'd like to start by asking a question to get an idea of how experienced the audience is with dissolved oxygen and temperature monitoring. So 1 second. All right, can you see the poll?
Yes, we can.
All right, so how comfortable are you with dissolved oxygen temperature monitoring? Are you brand new, you're not sure what it is, and you're here to learn? Maybe you're signed up to sample this year and it's your first time. Have you sampled before, but you're here for a refresher? Or are you maybe somebody who's done it for many years and could teach someone how to do it? Looks like we're pretty much all set. So it looks like a majority of you are not sure what it is and are here to learn, and that's fantastic. I'm glad to have you. Perhaps it's something you'll sign up for in the future. Some of you are signed up this year to sample it for the first time. And it looks like there's a few, just 3 of you who have done it for many years and could teach someone else how to do it. And even for you, I have a new piece of information this year, so I'm happy that I can share that with you. Okay, so how is dissolved oxygen and temperature measured? We have special meters. Sorry if that whole question came back up. Is it gone, Eric, the poll question?
I still see on mine, but you can X
So
out.
all you hosts just hit stop sharing and it'll go away. It's gone for me.
Gone for me.
Perfect. Okay. So as I was saying, you will have a meter that you'll need to measure dissolved oxygen and temperature, and it has a cable on it, and that cable comes in different lengths, but you'll be dropping the cable throughout the water column and stopping at different depths to take the temperature and dissolved oxygen readings. So this is what the agenda looks like for this presentation today. I'm going to go over what dissolved oxygen and temperature is and why it's important. Then I will go over how the MiCorps program is organized. Then we'll talk specifically about the equipment and how to take care of it. Then we'll talk about the procedure of how you go out on your lake to sample. And then we'll talk a little bit about end of year protocols and what to do at the end of the year. So first of all, what does dissolved oxygen and temperature measure? Temperature is pretty easy. It's how warm or cold the water is. And then dissolved oxygen is how much oxygen is dissolved in the water and then is available for aquatic organisms to use because fish and plants and other organisms need oxygen to survive just like we do. So I'm going to start and talk about temperature and why it's important. In your lake, you have likely noticed when you jump in to swim that as you swim deeper, the water gets colder and the water on top stays pretty warm. And this is because as water gets warmer, it gets lighter or less dense and then rises or floats to the top. The cold water is more dense and it sinks. And these layers are called thermal stratification. So by measuring temperature, you can determine how your lake stratifies. And this is a diagram of a common temperature profile of a lake in the summer months here in Michigan. So the upper layer of the water is warmed by the sun and the warmer temperatures, and it's called the epilimnion. And this includes that littoral zone, which is the area close to shore that's shallow enough where sunlight can reach the bottom, and then plants can use that sunlight to grow. The next zone is called the metalimnion. And this is where there's a rapid decrease in temperature and an increase in water density, so it gets heavier, and this is called the thermocline. And then we have the cold bottom zone, which is called the hypolimnion. Deeper lakes in areas like Michigan will often separate into these layers during the summer, thanks to those physical properties of water. And by measuring temperature, you can define where your thermal layers are. So now I want to talk about how temperature changes throughout our 4 seasons. We already talked about what many of the Michigan lakes look like in the summer. So we'll start with fall. So in the fall, the air temperature drops and the sun gets lower in the horizon and the daylight is shorter. And the water temperature in our region begins to fall. And then in addition, the winds are usually pick up a bit more in the fall, and they mixes the water and adds to the cooling effect of the air. And then this colder water, what happens is it starts to sink because it becomes more dense, and it pushes the bottom water towards the surface. And this process is called turnover. And as that bottom layer brings up accumulated nutrients from the bottom and mixes with the more oxygenated water near the surface, the entire water column becomes mixed. So then we get into winter, and the water keeps getting colder at the top during at least the colder winters. And the water keeps mixing until it reaches less than 4 degrees Celsius. And at that point, the water starts to get lighter again and floats to the top until it freezes at 0 degrees Celsius. The water underneath the ice layer is warmer, and that temperature range, like on this diagram, is really just a couple degrees, but that couple degrees is really important because it allows fish and other organisms to survive. And then in the spring, as the ice melts and it reaches 4 degrees Celsius again, it'll fall to the bottom, and that quote unquote warmer water is pushed to the top, and then turnover happens again. And this cycle repeats every year. In areas of the country where they don't have much temperature change throughout the different seasons, lakes mix year round, or at least several times a year, depending on weather conditions. So now we're going to switch gears and we're going to talk about dissolved oxygen. And I have a video that explains it better than I could, and we'll watch that now.
Tamara, you may need to turn on the share video computer audio option on
Oh,
your
I forgot about that part. Hold on. Okay. Can you remind me where that is?
on your share screen option. You should have a menu.
Advanced sharing
Yep,
options.
there should be an option.
Says one participant can share multiple. That's not the spot. Maybe it's under more.
Where I usually find it is when I first initiate the share. So you may need to stop sharing your screen and then
Okay.
restart, and there'll likely be a checkbox to share computer audio.
1 second. Mhm. So go to share screen, but
And where
there,
you choose what window you want to share, at the bottom of that box, there should also be a checkbox that says share computer audio or something like that.
oh. Yes, I see. Mm. Okay, let's try this again. How's that?
Working. Perfect. Thank you.
Thank you for your help.
Imagine a world where we weren't surrounded by air. Without the oxygen in the air that we breathe, we wouldn't survive very long. But what about animals underwater? They need oxygen too. Where do they get it? The answer is from the water, because water actually also contains dissolved oxygen. Dissolved oxygen is just what it sounds like. It's oxygen that's dissolved in water. What does it mean for something to dissolve? If you've ever mixed sugar and water, you've noticed that the sugar seems to disappear. But what really happens is that the molecules of water mix with and surround the sugar molecules, breaking up the large sugar granules to make a sugar-water mixture. More specifically, since the parts of the mixture are spread out equally and evenly everywhere, we can call this mixture a solution. So when we say that something dissolves, it just means that it goes into an evenly distributed mixture called a solution. Now, like those sugar molecules, oxygen molecules also mix evenly with water molecules to form a solution. In other words, oxygen dissolves in water. But how does the oxygen get there in the first place? Well, there are two main ways that oxygen can enter a body of water, like the ocean or a lake. One way is from the atmosphere, or the air around us. Oxygen makes up about 1/5 of the atmosphere, and these oxygen molecules are constantly bumping into and entering water. Even more oxygen enters water through photosynthesis. You probably know photosynthesis mainly as the way that plants around us feed themselves. But there's actually a whole slew of other photosynthetic living things aside from plants. From tiny green bacteria called cyanobacteria to little phytoplankton with crazy names like dinoflagellate and even crazier bodies. All these creatures can produce food through photosynthesis. But in doing so, they actually also produce oxygen, which then dissolves in the water. What happens to this dissolved oxygen? Remember that like us other living things, the animals, plants, phytoplankton, and bacteria living underwater also take up oxygen to live. Furthermore, oxygen molecules are continually shuttling back and forth between the atmosphere and the water. But note that there's always at least some amount of oxygen that stays dissolved, and this amount depends on water conditions like the saltiness and temperature of water, and how much dissolved oxygen there is compared to the oxygen levels in the air. Now, why does the amount of oxygen already dissolved in the water and the surrounding air matter? Well, it's the same principle as walking into a crowded room from an empty hallway. You don't want to go in, and the people inside are trying to get out. In the same way, if there's more oxygen in the water than in the surrounding air, then the oxygen moves to the roomier atmosphere. Or if there's more oxygen in the air, then the oxygen moves to the water. The principle is the same for the saltiness of water. If you've ever tasted seawater, you know how salty it is, and that's because there's salt dissolved in seawater. Well, those salts are also taking up space in the water. You can imagine that as adding even more people to your crowded room, and the more people there are, the less room there is for you. So the saltier it is, the less space there is for dissolved oxygen. What about temperature? Well, when things heat up, they start moving around. Imagine yourself in a crowded room again. As everyone starts jostling around, it's a lot easier to move out of the room. Again, it's the same for dissolved oxygen. The oxygen molecules warm up and they start vibrating, making it easier for them to escape the water. So let's sum that up. Dissolved oxygen enters water from the atmosphere and from photosynthesis, and then gets taken up by living things or exits into the atmosphere depending on water temperature, saltiness, and the amount of already dissolved oxygen. Now you're probably thinking, who cares what the amount of dissolved oxygen is? Well, remember that living things need oxygen to live, and the more oxygen there is, the more animals can live there. So scientists measure dissolved oxygen to find out how healthy a body of water like a lake or a river is. But animals also adapt to the amount of dissolved oxygen. Fish like salmon need a lot of oxygen, so they can only live in colder places, but fish like catfish can live in warmer waters because they need less oxygen. If you've ever wondered why the kinds of fish are different in different places, this is one reason why. Unfortunately, even these fish die off at very low oxygen levels, and humans have been decreasing freshwater oxygen levels in a process called eutrophication. Eutrophication is a big word that just means adding a lot of nutrients good for growing, like nitrogen and phosphorus, to a lake or a river, usually by pollution. That causes a lot of plants and cyanobacteria to bloom. Aren't plants good though? Don't they produce dissolved oxygen? Well, yes, but when they die, they sink to the bottom of the lake and decay there, and this decay uses up all the oxygen in the lake. With no oxygen to breathe, the fish and other animals die and the lake becomes unhealthy. So throw your trash properly and recycle. Together we can preserve our marine and freshwater ecosystems.
Okay, so I really like that video, except for the end, because although recycling is great, it's not going to help with eutrophication, but that's a whole nother talk. So, however, the video does make a lot of good points, and to review the amount of salt and the temperature of the water impacts the amount of dissolved oxygen in the water. Oxygen enters the water through the air or by photosynthesis from plants and algae. If you have too much algae, it could lead to low dissolved oxygen when they die. This goes with plants as well. Nutrients such as phosphorus speed up growth of plants and algae and speed up the eutrophication process. And understanding the dissolved oxygen levels in your lake is one more tool to understanding the health of your lake. So here's what the data you collect will look like. This is an example of a graph you'll be able to make with the temperature and dissolved oxygen data that you collect. You'll receive a graphing template or in addition, at the end of the year, when you receive your yearly report, the graphs will be all done and already completed for you. So let's talk about this graph. You can see that dissolved oxygen is the circles and temperature is the triangles, and temperature is in degrees Celsius. And you can see that around 9 milligrams per liter is, that's where the DO is up until about 20 feet. Can you guys see my mouse? I just was wondering if I should use something else.
We can hear, or we can see it.
Okay, good. Okay, so here's 9 milligrams per liter, and here is, it stays about that until about 20 feet. And then it starts to decline, and by 30 feet, the dissolved oxygen is less than 1, which would not support any fish and other living organisms. So most fish that are warm water fish species like bluegill and bass, they need around 4 to 5 milligrams per liter of dissolved oxygen. And then cold water fish need as much as 8. So now we'll look at the temperature. The temperature remembers in degrees Celsius, and at the water surface and throughout the epilimnion, it's about 20 degrees Celsius, which is about 68 degrees Fahrenheit. And similar to the dissolved oxygen, it stays pretty stable until about 25 feet, where it drops to 2 degrees. And 2 degrees in temperature. So it's dropping in temperature pretty quickly every 5 feet or so. And that's that thermocline that I was talking about. And then at about 50 feet, you can see that it's a chilly 8 degrees Celsius all the way to the bottom, which is about 46 degrees Fahrenheit. And so with this information, you can see that it was stratified into the epilimnion, the metalimnion, where that thermocline is, and then the hypolimnion. This is an example of what those graphs will look like when you get your individual lake reports. And this happens more often than you would think, where this dissolved oxygen, which is in orange, has a bump like all of a sudden at 30 feet. And people will often ask if something was wrong with their meter, why isn't it going down as it gets deeper? And what happens is that sometimes there's an algae that's really happy at a particular depth where it's getting a particular amount of sunlight and the temperature is just right, and they are just having a good time with lots of photosynthesis, and so there's an oxygen bump at that point. Okay, so now we're going to give that part of our brain a little break, and we're going to switch over to how the dissolved oxygen and temperature monitoring program works and the equipment that you'll be using. So first, in order to do dissolved oxygen temperature, you need to have a meter. And we have about 46 meters, maybe a little more. We got some new ones this year and I can't remember the exact number, but we have several that you can borrow. Some people purchase their own meter, which they run at least around, for everything that you need, and they run about $1,500 a piece. And so if you're interested in purchasing one, we require a particular kind. So please contact me if you're interested in purchasing a meter, and I can direct you to where to get one. You'll be measuring dissolved oxygen twice a month, between mid-May and mid-September, and we are distributing the meters right now. We have two types of monitors that we're currently using in our program. The older one is called a YSI 550A, but it is no longer sold and soon parts will not be available. So if you have a 550A that's working correctly and calibrates, you can keep using it. But our program, if you borrow one, we don't have any 550As to lend out anymore. We are switching totally to the YSI Pro 20s, which are just a little bit easier to use and easier to calibrate. This is what the dissolved oxygen probe looks like for each meter. This is the silver part here. This is the probe on a 550A. The probe here is this black portion. The yellow part is a membrane, which I'll go over more in a minute. For the 550A, you have a black protective cage. With the Pro 20, it's a stainless steel piece, and then there's the cap or the cover for each of them, and inside the cap is a yellow, not necessarily yellow, but a piece of sponge, and they're in these caps as well. You just can't see through it. This is a little bit more of a close-up for Pro 20 probe. Right here, this little silver part is the temperature portion, and then this membrane goes over the dissolved oxygen probe to measure dissolved oxygen. So this is an example of what a dissolved oxygen meter kit looks like that you will get in the mail. The newer ones come in a gray case like this. Some of the older ones come in more like a Rubbermaid type plastic container. And I will show you a few. I'm going to stop sharing a minute. That's what we decided to do. So that I'll show you in person what the different pieces are. This is the meter itself, and it has a connection on the bottom that has pins in it that you have to line up with the cable. This is the cable. Most of you will get 100-foot cable. Some of you get a 200-foot one, depending on the depth of your lake. This is the other portion of that will connect to your meter. And like I said, you'll line up some pins and twist it to connect it. This is your the probe itself. As I showed you in the picture, there is a stainless steel cover that comes off if you need to get to the membrane, which most of you will never need to do this, but it does come off. And then there's the cap, which has a sponge in it that will come wet. It'll just be damp. There won't be standing water in the cap, but the sponge will be wet, and that's important to protect the membrane and keep it moist. And then so in your kit will you'll have a set of your data sheet. There is a sign that says it's property of EGLE and to please return the meter with your summer phosphorus water samples and my contact information on it. There's also an extra set of batteries, a quick start guide so you can quickly look at the procedure. And then there's also a extra membrane and some solution, which I'll go over in just a minute. So I'm going to share my screen again. So for you, those 3 people out there who have been doing this a while, new this year is that we have a weight that can go on the bottom of the probe. Just a second, I'm having trouble getting. Well, geez, it's in my case, but it's hard to get up, but it's just a good picture here. So anyways, it goes into the bottom of the cage and it just screws in there. In the past, you might have had a lead weight on it, and we are moving away from using those because they're not good for the cords and we don't want lead in our lakes. This is a close-up of what the membranes look like that are needed and the oxygen probe solution that you'll need. And I'm going to show a video of how to change a membrane, but I want to assure you all, especially the ones who are learning this, that this rarely happens. I think maybe of the 45 or so that I give out every year, maybe 3 come back where they had to change the membrane. But these videos are available online and I'm available, so don't be set back by that. Hello, this video is to show you how to replace a membrane on your YSI 550A. If you're watching this and have a Pro 20, changing the membrane is quite similar, so you can watch this video as well. I have been trying to calibrate this sensor. This number is the percent saturation, and it's supposed to be between 93 and 98%. and it won't go any higher than about 85%. So I've turned it off, I've turned it back on, and tried calibrating it several times after a very long warm-up period, and it just is not working. So I'm going to show you how to change the membrane. Every kit comes with an extra membrane and some solution, and it'll probably be in a baggie similar to this. Here's the probe. We'll take the cap off. And then next we need to take this cage off, and we just twist it. Till it comes off. And then this yellow portion is the probe. And we'll twist that. And a little bit of solution will probably come out. It's not a big deal. Now I'm going to take this canister, it's an old film canister, which I think is kind of fun, and get the new probe out. There's nothing you need to do with it. Make sure you don't press or touch this portion in here. That's the membrane, and it's very, very fragile. So just hold it gently in your hand. Take your probe solution. There's not very much in your bottle, most likely, because you don't need a lot. Just shake it, and then put about 10 drops inside the cap. It's not essential that it's 10 drops. That just seems to be about the amount it can take without overflowing too much once you screw it back on. So this little portion here is your the part that measures temperature, and this part here reacts with the membrane to measure dissolved oxygen. We'll just put it back on, twisting it only until it's just starting to get tight. You don't need to really crank on it. And then we'll put the guard back on. And then we will try calibrating again. Remember to check your sponge and make sure it's moist, but that there's no standing water inside your cap. Put it on. Bring the meter back over. And for the 550A's calibration, it requires you holding both the up and the down button at the same time until it says CAL. Once it says CAL, you press enter. And the next thing that comes up is elevations, the elevation number, which is... I'm going to stop there because most of you won't be using a 550A, and I don't want to confuse you on calibration. Calibration is a lot easier with the new ones, and I'll go over that in a minute. So, you've seen the equipment, and next you're going to prepare for sampling. So you want to make sure you have calm and dry weather conditions, just like you do with your other parameters, and make sure you have safety equipment and a friend to help with the data recording. Check out the quick reference procedure checklist that's with your data sheets. And there's also a quick procedure list in your kit. Make sure you have all your data forms, and then turn on your meter for 10 to 15 minutes, and then calibrate your meter. Here's how to calibrate your Pro 20 meter. Calibrate, by the way, means that you're checking, you're checking the moisture inside that cap, which should be somewhere around 100% because it's got a moist sponge, and it's kind of like a little sauna in there. And you're checking to make sure that your meter is operating correctly and measuring around 100%. This video is to show you how to calibrate your YSI Pro 20 dissolved oxygen and temperature meter. It's really pretty simple. First, you want to check inside the cap that covers your probe and make sure that the sponge that's inside is wet. Always want to keep the environment for the DO probe moist, but it shouldn't be standing water. You just put that back on and then turn the unit on. You'll see at the top here, there's two measurements. One says milligrams per liter, mg/L. One says percent. The percent is the percent saturation, how much oxygen is in this container right now. And then the milligram per liter is what you'll be measuring when you put the probe into your lake. The temperature units are in degrees Celsius, which is what you want. And to calibrate, really all we have to do is hit this button here, press it, and then hold for about 3 seconds. And then it will say calibrating percent dissolved oxygen until it says calibration successful. And then you're all set. Notice it did go away, the calibration successful. So if it's taking some time and you look away, you might miss that. But if you wanted to double check, all you do is hit calibration again, hold it, calibration successful, and you're ready to go. Have fun. So that video is available online. I hope to update the membrane changing one with the Pro 20 as well. Just remember to turn on your meter for 5 to 10 minutes with the Pro 20, more like 15 with the 550A, so that it's warmed up prior to calibrating. There's a card inside the tub for reminders, and you need to calibrate every time you sample. I calibrate every time I sample. It's important to make sure your meter is working correctly so that you have accurate data. Okay, so now we'll take a look at the data sheets. The top of the data sheet is similar to the ones for Secchi and phosphorus, where you have the lake name, your county, your field ID number, your latitude and longitude, and then your names and dates and time and weather conditions. And then we have your sampling station depth. And you need to make sure you measure this before you begin sampling. In addition, you're going to need an anchor, and that's because you're going to be measuring dissolved oxygen temp for quite a while if you have a deep lake. And I'll get into that a little bit more in a minute. The second, well, this is page 1 again, but it's at the bottom. You need to circle which meter you're using. Most of you will be using the YSI Pro 20. This information for calibration values is only if you have a 550A. If you have questions about that, let me know, but you don't need to fill that out if you have a Pro 20. And then you need to draw a sketch of your lake and show where that deepest point is. So then you're going to proceed to your sampling location, and you need to anchor. If there are some of you out there who don't have an anchor, start talking to your neighbors and see if somebody has one you can borrow, or head to the store and get one, because for this parameter, you need to anchor. You'll anchor just upwind of the deep basin and drift back over that deepest spot, same as you do for the other parameters. And then you're going to check for the actual basin depth. And you can do this with a depth finder, or if you don't have a depth finder, you could use a weighted line. That's the line has been marked with feet. Or you can use your Secchi disc, which is also marked with feet. And you need to do this every time you go out. I have been out with volunteers who think they're at the deepest location. The deepest location on their map is 25 feet, and it was 10 feet, and they just had the location a little bit wrong. They're not the only ones who have done this, so just make sure you're checking for the actual depth and indicate that on your data sheet so we know that you did it. So then you're going to turn on your meter. If you calibrated back at your house, you don't need to calibrate again. But if you forgot to calibrate, you can calibrate right on your boat. That's not a problem. Then you'll take the cap off, but leave that metal guard. And you can add the weight if it's needed. They help keep the probe straight in the water column, especially if there's a little wind or a little bit of current. So now I'm going to go to poll question number 2. So here's a question for you. If the wind is calm, I don't need to anchor when taking dissolved oxygen. True or false? If the wind is calm, I don't need to anchor when taking dissolved oxygen measurements. All right, it looks like it's slowing down. I'll end the poll and share the results. The answer to this question is false. You need to anchor anytime you're taking a dissolved oxygen, because even if you don't have any wind, your boat is bound to drift a little bit, and then your meter cable will not be going straight up and down, and you will not get an accurate reading. Okay, poll question number 3. True or false? I only need to calibrate my meter when I'm having problems.
Tamara,
True.
while the question is being answered, maybe
Yeah.
you could address a question that came in on the chat.
Sure.
The question from David, I'll be sampling 3 lakes which are connected to each other. Do I need to calibrate each time?
No, I would say not. The calibration is partially based on elevation. So unless those lakes are really far apart, which I think in your case they're not, I wouldn't worry about calibrating every time. On the other hand, it's super easy. Like if you have a Pro 20 and not a 550A, it takes 3 seconds to calibrate. So if you forget to calibrate on those 3 lakes, I would you did it on one, but you forgot the others, I wouldn't worry about it. But if you have the time, I would go ahead and just calibrate at each lake. Okay, this one everybody answered correctly. This is false. You should be calibrating your meter every time you go out to sample. Okay, so now how do you actually take a measurement? You're going to start at 1 foot deep, and as you can see in this picture, your cables are marked with pieces of tape. Make sure it seems like the first thing I do if you're borrowing a meter from us is just take a look at your cable and see if the 1 foot mark looks like it's about right and the 5 foot mark looks like it's about right. It is electrical tape. Some of them have been going out for years and still are great shape, super sticky, but some of them do slip. So just kind of check that out. And then make sure your meters in milligrams per liter, because that's what you'll be indicating on your data sheet. And after you drop the probe in, you're going to move the probe with a slight jigging motion. You're moving your hand kind of like this, up and down, up and down. And that's to make sure that there is water crossing over that membrane. The dissolved oxygen reading is going to drift a bit, and once it's drifting maybe less than like a half a milligram per liter, go ahead and just take an estimate of what that is. Sometimes it will stop completely, but there are times where it seems to keep moving a little bit, and as long as you're within a milligram per liter, that's fine and isn't going to make a huge difference ecologically. And then you go to the next step on your data sheet, and you'll keep doing that until you get to about 2 to 3 feet above the bottom of your lake. You don't want the probe to go into the sediment. This does happen from time to time. If you notice when you bring your probe back up that it's kind of dirty, just swish it around in the lake water and clean that off before you put the cap back on. So this is the data sheet. It's page 2. And you can see the different depths that we require, 1, 5, 10, 15, 17 and a half, 20, 22 and a half. It gets every 2.5 feet in this range because that's where most or many Michigan lakes will have their thermocline. And so you want to take measurements more often. But you can enter additional depths. If you only have a 15-foot lake, and you want to get your thermocline, you might have to take measurements at 1 foot, 2 foot, 3 feet, or at least 1, 3, 5, and then 7, 10, 12, 15. So you will be able to eventually in our database be able to enter those individual depths in addition to the depths on here. Just keep note of that. And then at the bottom of your data sheet, there's a note to enter your data into the MiCorps data exchange by October 31st. And that the protocol is to make a copy of your field data sheets for your own records and then mail a copy by October 31st to the MLSA PO box. It's really important. I mean, it's important for all of the parameters that you take samples and turn them in because it's for your own use. But in addition, for dissolved oxygen, there's a limited number of meters. And this year, even we have some folks that need to share a meter where their lakes are fairly close to each other. And if you're not taking the data and entering it into our database, then essentially it's taking an opportunity maybe away from another person. So just if you're having trouble entering your data, just make that copy like you need to anyways and mail it in and we'll get it into the database. We want to capture your data. And then you'll have a blank piece of paper, of graphing paper where you can graph your dissolved oxygen temperature measurements if you want. This isn't required. And then we, as I said earlier, you'll get a graph with your annual report. So the end of the year, don't forget to return your meter with that summer phosphorus sample at the end of the year. You return it to the same location, and that way I have several meters in one location that I can then arrange to get moved to Lansing. If you forget, which happens, I forget things, it's human, or if you need more time, like if you're in one of the more northern lakes and you want to collect dissolved oxygen for longer in the season, just contact me first to make arrangements of how we're going to get that meter back to me. You might need to ship it, and so just keep that in mind. Another reminder is to keep your sponge damp. Don't have pooled water. I did have one come back this last year that was full of slime, algae slime that had grown because the whole cap was full of water. So don't have the cap full of water, just a really damp sponge. Make sure you disconnect the meter from the cable every time. This will help keep the cable from getting kinked. And the wires in those cables are fragile. And so even though it seems kind of heavy duty, if they get bent, it could cause the meter to malfunction. And then make sure the case is dry. This isn't so much a problem with some of the plastic Tupperwares or Rubbermaid, but the new cases that we have are really pretty airtight. And if you put that cable away wet, it can cause some problems. I opened one case this year and it was just full of mold, which it didn't ruin the meter. It just discolored it in some ways, but just was a good prompt for me this year to remind everyone to dry out your meter and then shut the case. But do keep your meter in the case until it's time to monitor. I have had one meter come back where the screen's a little pixelated in one area, and I think it's because something got sat on top of it. So just keep it in the case until it's time to do your monitoring. Don't kink that cable and disconnect the meter. And then also take care when you're rolling up the cable. And then keep your meter case dry. So here's the last poll question. Which of the following should you do when putting the dissolved oxygen temperature meter away? Should you turn off the meter? Should you disconnect the handheld and carefully wind up the cable? Should you remove the weight from the probe, which I forgot to mention that. So I'll give you this one. You should remove your weight from the probe and store it in the box. Make sure your sponge is damp, but there's no standing water. Or is the answer all of the above? And yep, everybody's star pupils. All of the above is the answer. And with that, I think we have until noon. So we have lots of time for questions if you have any questions. And here's my contact information. Please contact me anytime. That is a cell phone number, so you can also text me. If I don't get back to you, if it's the evening time, I'll try to get back to you the next day, or you can also try giving me a call.
Thanks, Tamara. That was really great and very thorough. I love your incorporation of the videos. I think those keep everyone's attention and keep things kind of interesting, and the quizzes too. We do have a couple of questions that have come in that maybe you'd like to address. First is a question about concern about if you use a dissolved oxygen meter in more than one lake, or if they get shared, even from season to season, is there concern about potentially spreading invasive species by moving a DO meter from one water body to the next?
I think that is a great question, and I'm glad it's been asked because I haven't gotten that one before. I would say that just make sure you don't have any pieces of plant or algae on your probe. If possible, it probably would be even better if you could rinse it under some water, but I'm honestly mostly for invasive species. There's not likely some kind of snail or zebra mussel is going to attach well on your cable. I'd be more worried about plant material. So just make sure as you're winding up your cable to make sure there's no plant material or algae on the cable as you're winding it up. And then make sure if the probe did go into the bottom of the lake, just swish it around in the water and make sure it is cleaned off before you put it away. And then if you're sharing with another lake, I would also say it's likely that you'll do it on different days and not not the same day. And in that case, you can dry it out as well. So it'll be fully dry before it goes into the next lake, and that would be helpful as well. Do you have anything else? Joe or Eric, since you're gonna do the invasive species watch later.
I think you covered it really well, actually, Tamara. Thanks.
Okay, yep.
Another question that came in, how do I reserve a meter?
So when you sign up for your parameters, that's how you reserve a meter. Everybody who signed up this year is able to use a meter. It's just as I noted, a few people are going to be sharing this year. Next year, I think, well, the deadline for signing up for dissolved oxygen meters will probably be March 1st. I think it was April 1st this year. I wanted a little bit earlier next year, just to make sure I have time to assign meters to people. So that's how you would reserve one.
Here's another question. Can anyone come out to assist us on our first measure to train us on site to ensure we're doing it right?
Yes and no. Like, generally I haven't taken a ton of requests for doing it, because if all 45 people asked me to come out, that just wouldn't be possible with my other work. But I am doing side-by-sides. I do 10 of them or so a year. And at those side-by-sides, I do whatever sampling it is you're doing. So if you're signed up for dissolved oxygen and chlorophyll and phosphorus, well, sometimes I can't do phosphorus because phosphorus is just one day of the entire year. But with chlorophyll, since you're doing it every month, and dissolved oxygen and Secchi, I can come out with you and make sure you're doing those correctly. So if you are interested in that, just send me an email and I'll consider that when I'm selecting. I try to select my side-by-sides based on new people, and also based on if we haven't been to your lake before. So chances are I'll get to you eventually.